Hi everyone, and welcome to Lesson 7-6, Dilations and Similarity in the Coordinate Plane. Now, you may not know what a dilation is, but you may have heard the word. Essentially, it's when a shape or an object gets bigger or smaller, and this creates similar figures. So let's look at some definitions. A dilation is a transformation that changes the size of a figure but not its shape. So you'll notice the big purple star has been dilated to get the smaller purple star. They are the exact same shape, but they are different sizes. Now, the scale factor is a number or ratio that describes how much the figure is enlarged or reduced. So if my original shape was the smaller star, then the new shape is the bigger star, and it's been enlarged. So the scale factor might be 2 if it's twice the size. However, if the original shape was the big star, then the scale factor would be a fraction, like 1/2 or 1/3 or 3/4 to get this smaller star. Let's take a look at an example. So here's example 1. The figure shows the position of a JPEG photo. Find the coordinates of the vertices of the photo after a dilation with a scale factor of 3/2. So what we need to do is find these corner points and then take each of those ordered pairs and multiply the x and the y by 3/2. So try and do that. Pause this video, do that, and then come back to check your answer. Okay, so you'll notice that point A was 0, 0. So I took the x and the y and multiplied by 3/2 to get the new point 0, 0. Point B is 0, 4, so I multiplied by 3/2 for both the x and the y, and I got the new point 0, 6. For point C, I got the point 3, 4 times 3/2, you get 4.56. And for point D, we had 3, 0 times 3/2 got me 4.55. And that's all we need to do to create an image from a pre-image. And you may remember those words back from chapter 1. You may not, but the original figure is the pre-image and the new figure is the image. And generally we put these little apostrophes here. They're read as prime, so it's A prime, B prime, C prime, and D prime. But that's how we find those. So it's time for a check it out question. Check it out number 1 asks you to find the coordinates of the vertices of the photo after a dilation with a scale factor of 1/2. So go ahead and pause this video and do that. Put it on a Google Doc that you can turn in at the end of this video lesson. And I'll see you soon for example 2. Okay, so in example 2, it says, given that triangle AOB is similar to triangle COD, find the coordinates of D and the scale factor. So notice what they've done. They've told us that the smaller triangle here is similar to the bigger triangle. And they want us to actually find out where D is. So what we're going to do is we're going to use the side lengths to create a proportion. Okay, so see if you can create a proportion to figure out what the x value for D will be. Now we know the y value is 0 because it's on the x-axis, but see if you can figure out what D is, and then come back here to check your answer. Okay, so what I did is I did 2, which is the short length here, over 4, which is the longer length, is going to equal 3, which is the short length, over x, which is the length for D. So I solved this proportion, I found out x was 6. So I wrote D as the 0.60. Now for the scale factor, we're going to say we're going from the smaller to the bigger. So I have to do 4/2, 4/2, which is just 2, and that's my scale factor. So it's time for you to try it. Now check it out, question number 2 gives you the same type of example that we just did. It says, given that triangle MON is similar to triangle POQ, and the coordinates of P are -15, 0, M is -10, 0, and Q is 0, -30, find the coordinates of N and the scale factor. Please notice for the scale factor that the values for MON are going to be on top of POQ so that this will reduce properly. Okay, so go ahead and do that. Pause the video and then come back for example 3. Okay, so in example 3, they have given us a graphed figure with these ordered pairs, and they want us to prove that the triangles are similar. Now, there are some shortcuts to similarity, but my favorite shortcut is angle-angle similarity. And in angle-angle similarity, you just have to show that there are two congruent angles. So one angle pair from ABC and DEA has to be congruent, and then a second angle pair also has to be congruent. That's my favorite way to show that two triangles are similar. So let's see our steps. Okay, so step 1 is always to graph. They don't always give you the graph, so you always have to graph it first. Now, step 2, like I said, I like to get congruent angles. So you can use the fact that they share angle A, but then you need to find another angle pair. So you can use that angle A is congruent to itself. But in this case, I'm just going to figure out if BC is parallel to DE, because what that's going to do is it's going to get me corresponding angles that are congruent. So I can get angle ABC is congruent to angle D, and angle ACB is congruent to angle E. So I just have to show that these two lines are parallel, and then I can use that. So the way we do that in a graph figure is we use slope. So for slope, for BC, it rises 1 and it runs 1, 2, 3, 4. So that's a slope of 1/4. And for DE, it rises 1, 2 and it runs 1, 2, 3, 4, 5, 6, 7, 8. So that has a slope of 2/8. So you'll see that I did my work here. BC has a slope of 1/4, DE has the slope of 2/8, which is 1/4. So that means that BC is parallel to DE. Now I can name my congruent angles, and I would note that we used corresponding angles postulate. And then finally, I would go to step 4, which is write a conclusion. So I would say that the two triangles are similar by angle-angle similarity. Now I know this is set up like a proof, but with coordinate proofs, it's essentially just showing all your work and explaining your steps. So make sure you do that, and you'll be good with this type of proof. So let's try it. Okay, so check it out. Question number 3 gives you these 5 points. They want you to prove that triangle RST is similar to triangle RUV. Now, I know you can't really do a graph on your Google Doc, so you can simply just show some of your work so that I can see that you followed the steps properly. Just write everything out and then come back to the video for the last example of this lesson. So example 4 asks you to graph the image of ABC after a dilation with a scale factor of 2. They gave you these points for A, B, and C. So what we need to do is we need to do what we did in example 1. Take each point, multiply both the x and the y by 2 to get our new points. And then we're going to go ahead and graph it. So pause this video, do that work, and see if you get the same points as I do. Okay, so what I did is I took my ordered pairs and I multiplied both the x and the y's by 2. So I got A prime is 4, 6, B prime is 0, 2, and C prime is 6, 0. And then I just put it all on a graph, and you'll see this red triangle, which is bigger, is my image, and the blue triangle is the pre-image. Okay, so now you're going to try it. Check it out. Number 4 asks you to graph the image of triangle MNP after a dilation with a scale factor of 3. They gave you A is 2, 3, B is 0, 1, and C is 3, 0. Now, again, because you're using a Google Doc, I wouldn't expect you to graph this for me, but you can just write the new coordinates on your Google Doc. You don't actually need to show the graph. If you wanted to, you could take a picture and put it in, but you don't have to. That's it for this lesson, so let me know if you have any questions, and I'll talk to you soon.